Welcome back. So let's continue with the last few lessons of Module 1. Last time we were able to build a anatomy of SHL1, taking measurements and then creating the Zacro and URDF. And now we're going to bring it into Isaac Sim, but before that we need to make sure that the ROS2 bridge is available. So we need to follow this RCLPY custom ROS2 packages and workspaces with Python 3.11. And to do that, we start by cloning this workspace. And then we go into the workspace folder and we build, which is basically a Docker container. And then once that's built, we can go and source that particular workspace. There are two workspaces that we need to source to enable the ROS2 bridge. So that one is the ROS2 Python 3.11 build. And we also source the ROS2 workspace, both of which are available after building that container. So this is necessary to make sure that ROS2 bridge is available because we are going to make Isaac Sim communicate with ROS. And why do we need that? Well, to bring our robot into Isaac Sim, we need to run that package that we created last time where we could display our robot with RViz. So we go back to that package that you cloned last time and we run the display launcher, which brings RViz, and we can see the robot there, the full robot. We have so if we have a look at that launcher, this particular node here is the robot state publisher, which is in charge of publishing the most of the joints and links, in particular the fixed ones. And then we have the joint state publisher that will be in charge of publishing the state of the moving joints. Okay, and that's the sliders that you can see there that we can use to control the robot. So those two nodes are publishing all of this information, and we can use then the ROS2 bridge to let Isaac Sim have access to all of this information, and then that will allow us to import a robot into Isaac Sim. So here it is. You can see it. It has all of the stuff that we created in the previous lessons. So now we need to go back to this other terminal where we're gonna open Isaac Sim, and we need to make sure to also source the workspace of our course, because Isaac Sim needs access to some of the meshes of the robot. Otherwise, Isaac Sim won't be able to see the meshes of our robot, like the cameras and the battery, which are meshes. So now we can go and run Isaac Sim. Okay. You should be able to do this if you follow the installation instructions for Isaac Sim, which we won't be covering in this video lesson, because you can follow it on your own from the official documentation. So this is the main interface of Isaac Sim. So we can use the import from ROS2 URDF node importer, but it's not available by default. You need to go to extensions to activate it. So by default, it's not activated. You can type something like ROS, and if you look at the options, there's the ROS2 simulation control, which is not that one. Sorry, it's not that one. So there's the ROS2 bridge, which might or might not be active. So you need to activate that one. But the one we're looking for is actually the ROS2 description URDF importer, which will listen to that particular node that is publishing the information of the robot and pull the information from it. In particular, it's going to listen to the robot description node. So we open it, we extend a little bit more so we can have more access to everything. And here in node, you type robot state publisher, which is that node that I showed you previously from the launcher, and it will automatically update the list of joints, and you should be able to see 12 joints right? 6 that are for steering and 6 that are for moving the wheels. So something very important, this is not a static base, it's not a cobot or an industrial arm, it's a moving base, right? It's a moving robot. So you need to change that to movable base. Some other things that we need to take care of is we will keep the natural frequency as the joint configuration for now. And the drive type, we will keep it as force. Don't worry too much about those things, what those means. Just keep them by default. But you can read more about them if you are interested in knowing why. But most important here is by default, all joints will be set to position, but only the steer joints are positioned. We're gonna set an angle, which is like a position to steer the robot, so that's fine. But the drive joints are not position based, they are velocity based, right? You're gonna send velocities to them to move the wheels. So make sure to go to all of the drive joints and change them to velocity. You should have 6 of them. Okay, so at the end you should have 6 position and 6 velocity targets. Okay, so confirm. So again, position is because we're gonna set an angle to steer to, and velocity is because you're gonna drive the wheels at a certain speed or velocity. Don't worry about the natural frequency or the damping factors. We can tune those later. For now, we are not quite sure what those values should be, so we leave the defaults. Then collision from visual, we already added collisions to our URDF, so we don't really need to activate this. You can leave the defaults for collider type and for the rest. Now, one thing that is missing, we need to specify where we're going to output our USD. Remember, USD is the official format supported by Isaac Sim. So you type there, we're going to save for now on the desktop, and we're just going to call it SHL1 Isaac for now. So that will create a folder with that name, and within that folder, it's going to import our robot as a USD, right? So Isaac Sim doesn't understand URDF, so we need to do this to convert our URDF or Zacro into USD. So again, verify that the joints are velocity and position, velocity for the drive and position for the steer joints. And when everything is ready, click import. And that should do the trick for us. Okay, so we close the window, and SHL1 is right there. Beautiful. So, are we done with this thing? Well, first of all, notice that there's no floor. And if we run the simulation, well, SHL1 just fall into the abyss because there are no physics, there is no floor. So it's just like a limbo. So we stop it, we run it again, and SHL1 falls because there's nothing. It's limbo, right? It's the void. So in the next session, we're gonna add physics and at least a ground plane so that SHL1 doesn't fall to the abyss. See you next time.